saw the cotangent graph. That was the first reciprocal. You did cotangent.
We literally did all this in one day and then.
Ah. I didn't know you did cotangent. So you did tangent last year. I realized that. I didn't realize you also did cotangent.
Yeah, it was all like one day.
So we're going to look at the other two reciprocal functions. So we'll do a parent graph first of, we'll just go with cosecant. So y equals the cosecant of x, which is the reciprocal of sine. So what I always do, and what I will have you do as your method for graphing a cosecant function of any sort, is treat it as a sine function first, as kind of, and that's going to serve as a guide. So I'm just going to sketch the sine parent graph. 0 to 2 pi, starts on the midline, pi is another, and I'll do an amplitude of 1, obviously, as a parent graph, but I'm going to skip every other line for 1. So I have a max at pi over 2 and a min at 3 pi over 2. So there's just a sketch. And I'll go this, well, yeah, I'll go this way too. So we use the whole graph. Okay, that's just a guide. So do that lightly. We're probably going to go back and end up erasing that. We are just reciprocating to get to the cosecant graph. We're just reciprocating all of these values. So most notably are our zeros, because when you reciprocate zeros, what do you get? Undefined. So where the zeros are on my sine graph are going to go asymptotes on my cosecant graph. And we know that when a function approaches an asymptote, now keep in mind, this is, I'm going to kind of erase and make this sine guide more of a dotted graph because it's not my actual graph. Or you can lightly erase the whole thing if you want. But I want to see where it kind of was, because like I said, that is definitely my guide. My entire cosecant graph depends on where the sine graph was. So we know that as we approach asymptotes, the graph is shooting off towards infinity or negative infinity. And so if we take a lot of these y values and reciprocate them, like let's take this one, a really teeny tiny y value. So just past 0, let's pretend we have a y value of 1/100th, right? What's the reciprocal of 1/100th? 100. So this is going to be going towards positive infinity as we approach this asymptote from this side. This one has a y coordinate of 1. What's the reciprocal of 1? 1. So that point is still going to stay there. So and then if we go over here and you come just to the left of pi, the sine graph had again another very small value. Let's pretend 1/100th. What's the reciprocal of 1/100th? 100. So it's way up towards positive infinity. So what you get here is a parabola-looking shape that sort of is reflected, I would say, off of the maximum. You see what I mean there? And then if we go slightly to the right of pi, the sine graph contained, let's pretend, negative 1/100th. What's the reciprocal of negative 1/100th? Negative 100. So that would be kind of like negative infinity. What's the reciprocal of negative 1? Still negative 1. And then again, slightly before 2 pi, the y value on our sine graph was negative 1/100th at some point. So now when you reciprocate that, it's negative 100, so you get that negative infinity behavior. And it's kind of tapping out at that negative 1 and then turning back around, so that parabola-like behavior. And then this is just going to repeat. So you're going to have, off of every minimum, you're going to have sort of this reflected parabola look. And off of every maximum, same thing. So that is your graph of the cosecant parent graph. Stephen. Perfect. Yep. Yep. And we're going to see that. Yep. So the sine curve, whatever the transformations are, that sine curve is going to be the guide for our cosine curve. Josh. Yes. We will discuss that. There's going to be something a little tricky about that, but yes, you've got the idea. I think. Say your question one more time. Pi over 2, 2. Yeah. That's where the maximum of my sine curve would be. It's going to be a little bit tricky, though, because you're not going to really reflect off that maximum because that maximum is not at 1. So the reciprocal of 2 is not also 2. It works with 1 that way because the reciprocal of 1 is 1. But if your maximum was at 2, what is the reciprocal of 2? 1/2. So it would actually go down here. It would still be a parabola-like shape, but you'd have to reciprocate the maximum value to get your new minimum value, I guess. Okay, so we will see that. And then for our secant parent graph, so y equals the secant of x. This is, of course, the reciprocal of cosine. Was it in here yesterday where someone said the word inverse and I was really quick to jump on that and say absolutely not? So maybe it must have been my period 7 class, because I know it was in this room. Someone said, oh yeah, this is just the inverse. This is not the inverse function, okay? The inverse function of cosine is this. That's not the same as the reciprocal function of cosine, which is what we're doing today. So we will get to these graphs, but it's not where we are yet, okay? So at any rate, this is going to work the same way. Our cosine curve is going to be our guide. So I'll tap out at 1, negative 1. I'll draw my parent graph for cosine really lightly. I'll probably go back and erase that. But again, asymptotes go where the zeros are. And you're going to see a very similar thing here, because really small positive, when you reciprocate, is going to go to a humongous positive. Same thing over here. Really small positive, when you reciprocate, is going to go to a humongous positive, aka towards infinity. And then reciprocating 1 is still 1. And so you just sort of use that reflecting thought process. So the secant and cosecant graphs look very similar, wouldn't you say? What's the difference? Right, the location of the asymptotes. To be truthful, Correct. Yep. So they are just a shift off of each other because same reason the sine and the cosine graphs are just one shift off of each other. Any sine graph that you think is a sine graph can also be written using a cosine graph. Yes? We looked at that the other day. We wrote something as a sine graph, and we're like, okay, well, what would we write it if we wanted to treat it as a cosine graph? You can do that because they're only shifts off of each other, and this is the same thing. These are just shifts off of each other. So it's really difficult to look at a graph and say, okay, well, what's the equation for that? Because there's an infinite number of possibilities. This could be a secant graph or a cosecant graph if you want to consider the cosecant graph has been shifted. If I take the actual cosecant graph and I shift it pi over 2 units to the left, well, now it's sitting on top of the secant graph. So I tell you this only because on multiple choices, and you can now start to look at your review packet for next Wednesday's test, but you might see a graph and it says, which of the following is an appropriate equation for the graph that you see? And it is a tougher skill to like go through 4 different equations and see which one is possible. Because you can't just look at it and say, oh, that's definitely a secant, because it could be a cosecant written with a shift. So start to take a peek at some of those multiple choices. Actually, if we have time at the end here, I might pull some of those up. So those are our parent graphs, and that's the process. Now getting into some transformations. So, and this tells us, use the graph of y equals 2 sine of 2x to obtain the graph of y equals 2 cosecant of 2x. So we are, essentially our goal is to graph this guy, the cosecant one. But to do it, we're going to graph the sine curve first. So, what has happened to our period? 2 pi over a b of 2 is just pi. So our sine parent graph is going to have a period of pi. With an amplitude of 2. And we can do a couple cycles of that. I'll just do the positive side of things. We could obviously continue this for as long as we needed. So what you do to translate this sine graph to now the cosecant graph is draw on your asymptotes. I'll just do from 0 to 2 pi. And then we're still going to have that reflected sense between each set of asymptotes, but now this is going to touch on Josh's question earlier. The key point that we want to be considerate of is where the maximum of our sine graph is, because that's going to turn into a relative minimum for our cosecant graph. So what is the reciprocal of 2? 1/2. So the minimum is actually going to go down there, and then your parabola-like feature will just do that. And so negative 2 is going to have a negative 1/2 reciprocal, so that one does that. And then we just do a bunch of these in between each set of asymptotes. And then lightly erase your sine graph, because that was just a guide. So as far as critical points are concerned, I'm really only concerned with these relative minimums, relative maximums. So like this one, for example. Pi and 2 pi, so 3 pi over 2. What is this going to be? What's halfway between 3 pi over 2 and 2 pi? 7 pi over 4. So that point would be 7 pi over 4, comma, negative 1/2. Couple strategies to finding the halfway point between 3 pi over 2 and 2 pi. Anytime you're looking for a halfway point, you're looking for an average, right? You could just average these together. So add them up and divide by 2. So that's going to be 3 pi over 2 plus 4 pi over 2 when I get a common denominator. That's going to be 7 pi over 2 divided by 2, hence the 7 pi over 4 that Connor came up with. You could also say, well, this is 3 pi over 2 and this is 4 pi over 2. What's halfway between 3 pi over 2 and 4 pi over 2? 3.5 pi over 2, right? Can't have a decimal in a fraction, so if I just double, it'll make it 7 pi over 4 that way too. Okay, any questions with that? And this next one wants us to graph this secant function. So what is the equation we're going to use as a guide? Kyle? Okay, y equals negative 3 cosine x over 2. Yes. Now, let's see. Find your new period. 2 pi over 1/2 is your b value. So it's 4 pi. Okay. So this gives us a specific range from negative pi to 5 pi. So I'm going to go this way with my y-axis way over here because I have a little bit of negative space, but not a ton. And I'm going to go every other is pi. So this will be my negative pi, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. Now my cosine guide. What's the starting value of my cosine curve, the starting point of my cosine curve? 0, negative 3. Very good. So I will count by ones. It's a negative cosine, so it starts at a minimum. And the period is 4 pi, so at 4 pi it's going to end also at a minimum. Where's my maximum going to be then? 2 pi. Where are my zeros going to be then? So there's just one cycle. Now I need to continue this through so that I'm hitting the entire domain that they requested. So I need to bring this back up to 5 pi to kind of finish that out, and bring this back up to pi, negative pi rather, to finish that out. And this is just my guide. So insert asymptotes. And then think about your maxes and mins being reciprocated. So starting with our negative 3. What's the reciprocal of negative 3? Negative 1/3. So teeny tiny. And then this is going to come down. I'm going to get rid of my guide right now because I don't want to have to erase a lot of my... I can still see where it was. And then over here, there was a maximum on the top of our cosine curve of 3. The reciprocal of that is 1/3. And then we just do one more of these negative 1/3 ones between the last set of asymptotes. Any questions? We're good?